Hello and welcome. So in this tutorial we'll learn that how we can make RBD or Vellum or any other kind of geometry solver affect or be affected by Pyro. And we will also learn that how we can make them affect each other simultaneously. But since this is a intermediate tutorial, you must already know the basics of DOPs to learn from this tutorial. And before we jump to Houdini, if you are new to my channel, then you can subscribe my channel, and you can also join my new Patreon channel on patreon.com/revme, where you will get yearly access to my videos and the plugins and application I make, and you will also be able to vote for the next tutorial I upload. So now in Houdini, we will first create the Pyro and the RBD or Vellum source. So we'll create a geometry node for that. And inside this geometry node, we'll create a Pyro configure fireball, which will give us a basic template. We'll remove this add node and everything except the volume rasterize attribute and Pyro burst source. So let's delete this. And now you will see that we have a basic Pyro source. You can also control this by going on the Pyro burst source node, which creates a lot of points with the density and temperature and velocity attributes, which we rasterize on the volume rasterize attributes node. So you can change the shape offset, and you can also change the initial size, and the voxel size of this volume rasterize attribute node is controlled by this trailing separation, so you can also change it later if you want. We'll keep it on this value so that our previews are fast. And then on the burst animation tab, you can control the duration of this. So we'll set it on something like 6 so that it ends quickly. And you can also change the burst components. So for example, you can change these density or temperature or burn attribute values. For example, we can increase the temperature a little bit, and I will tell you why I did it later. So this will be our source, as you can see, and now we can drop down a null and connect it to this and name this Pyro src. So this will be our Pyro source. Now we'll create the RBD or Vellum source. So we'll create a box for that. We'll keep it as simple as we can. I just want to give you an example. So we'll start with a box with the lowest polygon count possible, and we'll use this as a RBD source. So we can drop down a null, and we'll rename it this to RBD source. And now we will also change the center of this so that it is not in the middle of this of our origin. So we'll copy the size of this box on the y-axis and paste the relative reference of it on the center's y-axis, and then we will divide it by 2 so that it stays on the surface. So this will be our RBD source. Now we'll drop down a subdivide node to make the Vellum source. So we'll subdivide it with the open subdiv bilinear algorithm, and we'll increase the depth to something like 3, and we will create a Vellum soft body with this. So we'll drop down a Vellum configure stretch soft body, and then connect the first input of this to a subdivide node, and it will create the constraints and configure our surface. And you can also preview this by using the Vellum solver node and change the Vellum constraints values so that it looks as you want. And we can enable the ground plane over here, and then we can try and solve this. And this is how it looks. We decrease the y offset of this ground plane, you will see that how this looks. It looks like a soft body. So we'll delete this Vellum solver now, and we'll drop down a null, and we'll name this as Vellum source, and we want another null for the Vellum constraints, and we can also add surface to this so that it is more clear. So Vellum surface source and Vellum constraint source. So now since the source is set it up, we can drop down a DOP network. And now inside this DOP network node, we will create a smoke object sparse, or you can drop down a empty object and use the smoke object configure node, this one. And after this, we'll use a Pyro solver node. Pyro solver is sparse. We'll use the sparse solver so that it is fast. And then we'll connect this to the output. And now we have to add our source. So we'll use a volume source node for that. And let's also rename the smoke object to Pyro obj. And the volume source node, many users think that this is applying a data, but this is actually a solver. So if you look inside it after you initialize it, so that it creates the nodes inside it, as you can see, it actually has solvers. So you will see these gas microsolvers attached together in a enable solver. So actually what it does is that, so if we connect it to our sourcing input, if we set a SOP path over here, it will work like a solver, and at the specific time when this solver is called, it will take the SOP level volume and feed that into your Pyro solver's field. And it is also necessary to put it only in the sourcing input, because there might be some solvers which need to be called before this solver, and there might be some solvers which need to be called after this solver. So the order also matters. So now on the volume source node, we'll set the SOP path to the Pyro source, and then we'll initialize it with the source smoke configuration. And now it will take these source volumes and turn it into the DOP level fields. And what the fields are, they are the DOP specific type of data for representing the volumes. And you create those data with these, for example, the scalar field node, which creates a volume field with a single component value for all of the voxels. And just like this, you can create a vector field and many other kinds of fields. So if you middle click on this Pyro solver sparse node, you will also see that it has many fields already created, for example, the density field or the temperature field or pressure or collision velocity. And you can also see the data type for them over here. And you will see all of those fields attached as a data inside this smoke object sparse node. As you can see, scalar field, you will also find some vector fields, and we will talk more about these fields later in this tutorial. So now we want to bring our RBD source. So for that, we will drop down a RBD object, and we'll set the SOP path to the RBD source over here, and then we'll use a rigid body solver for this. And don't use the RBD solver or the bullet solver for this, because they are both switchable from this main node, and this is much more useful. As you can see, you can change the solver engine over here, bullet or RBD. The engine which we want to use right now is the RBD, and we are using the RBD solver because RBD solver handles single or a few objects much better. The bullet solver is meant to handle much more dense RBD simulations. And now we can drop down a gravity force node and plug it over here. And we can visualize this right now. And we can also visualize this Pyro solver sparse node. It doesn't need a gravity node force node over here. So we can visualize it without that, and you will see that this works too. So what we want to do now is we want to make the RBD object affect the Pyro object. And to do that, you already know we have to create relationship. So we'll create a merge node for this, and the RBD solver will be our left input because we want the left input to affect the right input, and then we want to have the Pyro solver as our right input. And we also want a ground plane, so add a ground plane node, and we want to make the ground plane affect both of these objects after this merge node. So we'll drop down another merge, and we'll make it affect the RBD and the Pyro object. And now if we set the output flag on this output node, and actually let's offset this box so that we can see it better. So we'll set the center on X to like this, and we'll also increase the size of this something like this so that we can see that if it affects the Pyro object or not. So if we resimulate, you will see that it actually works. As you can see, if we drop down a DOP import field node over here on the shop level, we'll see it clearly. So you have to set the DOP network to the DOP network node, and we'll set the default object to the Pyro object, and we want to import the density field, the uppercase. So as you can see, it correctly evades the box. So if we lower the offset of the box on the x-axis, something like 3 for example, or 2, then we will see it better. So let's let it run now. As you can see, it correctly evades the box. If you see the box where it is right now, as you can see, it is here, and it correctly evades it. So now what we want to see is that how does this work? And the reason why it is working, if I quickly show you, inside the Pyro solver, we have this smoke solver which does the actual job, smoke solver sparse. And if you go inside it and press Ctrl plus F to launch the fin node pane and search for collision, you will see this build collision mask node appear. If you click on that, this is a gas build collision mask node, and this is the node which creates the collision for this smoke simulation. So if you, for example, have this RBD object with a relationship to this Pyro object, and the relation type is collision, then it will take that geometry and also add a sign distance field volume to this object which is affecting, and also add that to our collision field of this solver, this object. And the RBD object by default has uh, a sign distance field applied as a data inside the geometry as a subdata. As you can see, this volume data, even if you remove this Pyro object from here as a affected object, still you will see that we have this sign distance field volume. So that gas solver won't have to calculate this sign distance field for us, and it will use this volume. But even for the solvers which don't have this sign distance field applied, it will also work for them, because the solver will create that for you. If I create a Vellum object for which we also prepared the source, if we set the initial geometry to Vellum surface source and initial constraints to constraint source, and then apply a Vellum solver data to it like this, and also apply the gravity force, and let's replace the RBD object with this Vellum object, and then if we make a relationship between the Pyro object and Vellum object, you will see that if we cut it for a minute, you will see that the geometry data doesn't have any sign distance field volume data applied, as you can see. But after you make a relationship between the Pyro object and this Vellum object, you will see that after the second frame, you will see that this volume sign distance field data has been created. And now you will also see that this Vellum object also affects the Pyro object. If we run the simulation, you will see that this also works. And this visualization, which you can see as this glitch over here, is also the visualization for the sign distance field it created. It just creates a ISO surface of that sign distance field. So this is how you make a geometry solver affect a Pyro solver. Now we will learn that how we can make the Pyro solver, the Pyro object affect this RBD or Vellum object. So we'll cut this file, and now we will make the Pyro solver affect the rigid body object. So we will set it as a right input, so that this Pyro object has a relationship of a factor to this RBD object. But even when we have this relationship set to collide relationship, it won't work, because there is no way to for the Pyro object to apply a force to this rigid body solver or affect it in any way. So to make the Pyro object affect this RBD object, we will have to do something on our own. But first, since our collide relationship is obviously not working, we'll set it on empty relationship. And what this will do is that it won't create any kind of collision relationship between these two objects, but it will create a empty relationship, which means that it will only make a order between how these two objects get solved. So obviously the affector object will get solved first before the affected object. And now to make this work, we'll use a node called field force node. And this node lets you use a vector field to make a field force, so that according to the vector field, the force will be created, and that will affect the object which it is applied to. So what we want to do is we want to use this pressure field, which is a scalar field, and use that to project force to this RBD object. And to fetch that data after this Pyro object has been solved in this RBD object, and use that for this field force, we will use the node called fetch data. And on this node, you have to provide the source object name. So we can set it to Pyro obj, and you can also provide object ID over here if you want. And then we have to provide the source data name, so we can quickly look at the geometry spreadsheet. And as you can see, the pressure data has the name of pressure 2, so obviously we have to enter it over here. And you can also change the fetch data name over here with this data name parameter, but we don't want to do that. And now we will connect this to this second input of this field force, which accepts a scalar field or a vector field. And now if we take a look at our viewport, you will see this blue colored viewport. This is because we have this field force guides turned on. So if we scale down the force vectors, you will see that it has created a force field, and you can also see how where this is pointing to us, so how your objects will be affected with it. So now what we can do is that we will turn off this show guide geometry, and now if we take a look at the simulation, it is still not affecting the RBD object, because It might be too heavy since we increased the size and the density is high too. So to make this affect this object, we'll scale the force to something like 1000, or we can lower the size of this box. So we can not the uniform scale, we'll decrease the size of it to something like this. And now if we try this now with a decreased force, you will see that this works exactly how we wanted it to work. And the Vellum object will work with this too. If we plug it to this field force and replace this RBD object, you will see that it actually doesn't need this much of force, so we can decrease this to something like 10 and it will still work. I think we have to decrease it to even lower. Let's see if one works. And as you can see, it does work. And you can play around with the scale force so that you match your liking. So this is how you make a Pyro object affect another geometry solver. So now we'll see that how we can make them affect each other concurrently or simultaneously. So the first thing we want to do is to make the geometry solvers affect the Pyro objects. So we'll reverse this relationship and we'll set it to collide relationship again so that it works. And let's use the RBD object for this test. So now what will happen is that since we have this collide relationship between these two objects and this RBD object is the affector and the Pyro object is the affected, the RBD object will be simulated at first and then after that the Pyro object will be solved. So the RBD object will collide with this Pyro object and affect it, but the RBD object won't be affected. But what I want you to remember is that even before the Pyro object is simulated, we still have the previous frame data for this RBD object, and we will still be able to fetch that using this fetch data node, and that will also work. So what will happen is that it will take a previously sourced Pyro pressure field and then create the field force and push the RBD object with it, and after that the Pyro object will be solved and then it will recognize that pushed away RBD object as a collision, and this will happen in a iterative way. So now if we run the simulation with a increased field force scale, so we'll set it to something like 1000, and then you will see that the box is being affected and the Pyro Pyro object is being affected too. So if we make the box bigger so that we can see, you will see that the Pyro object is also being affected. If we take a look outside on the drop import field node, as you can see, it clearly makes a mask for the box. And the box also gets affected. If we increase the field force even more, you will see that more clearly. So now you will see that it is being affected. And the Pyro object is also being affected. And this will obviously be slower, but this will give you more realistic results. So this is it for this video. I hope you liked it, and if you liked it, then you can like this video and also subscribe to my channel, and you can also join my new Patreon channel. So thanks for watching.